Hello, my name is Harley Fuller and this is my Lab 5 video report. For the agenda today, I will be discussing the problem that we have successfully modeled, showing some of the experiment performed and its results, going through calculations that help explain the reason behind our experimental results, and how we can code a model on computer programming. To introduce this experiment, I will go over the basic goals, materials, and procedure that was used. Our goal is to explore the fundamental principle of Faraday's law. To do this, we will be dropping a magnet through a tube of aluminum foil. The materials used in this experiment consist of a magnet, a tube of aluminum foil, and a smartphone with a magnetometer app. To begin, I set my phone propped up to record the experiment. This is to get the timestamps for when the magnet enters the tube and leaves the tube. Once the preparation was finished, I moved on to experimenting, which I will show on the next slide. For the experiment, we were asked to drop the magnet through the tube of aluminum foil and observe the results. I did this 5 separate times and recorded the timestamps. It seemed to take a lot longer for the magnet to fall through the aluminum foil as opposed to dropping it outside of the foil. Seen here, I got an average result of 0.85 seconds. I believe I had a smaller result compared to my peers because I had a thinner roll of aluminum foil. This would have had a lesser effect on the magnet, therefore restricting its fall even less. If I were to use a roll with more aluminum foil, the magnet would have fallen slower. Another option would be to use a roll with a smaller radius. The closer the aluminum foil to the magnet, the stronger the attraction and the slower it will fall. I have also included my mu value from the previous lab. As well, we will use it in our later slides. On to the last part of the agenda. I would like to discuss the coding aspect of this lab. The code takes the value of mu and the dimensions of our aluminum foil and magnet. We then create a tube in the program and simulate our magnet falling through it. It also graphs the entire process, looking like a slope that plateaus and comes back down. This records velocity versus time and helps us compare our computer-generated model to that which we have actually recorded. In conclusion, I would like to answer some questions. What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? In short, a bigger current means it would take a longer time to fall. We would also want it to tumble less, as it seemed to spin inside of the tube. What if holes or slots were cut into the tube? How would this affect the ring currents in your model? If we cut holes in the tube, it would fall faster because there would be less aluminum foil surrounding it. There would not be solid rings, therefore the current would not flow effectively. Through this lab, we took common household objects and experimented with the physics principle of Faraday's law. This lab helped us visualize the principle in person and on a computer program. All in all, this concludes my Lab 5 video report. Thank you for watching.